Self-test for 4.7. We're just going to do this last question and then we're going to get out of here. Or I'm going to get out of here, which I would like to do. Okay, so what do we got left? We have this one last question, which says, alright, so we're told some information about red blood cells. Now, they undergo hemolysis with a pH of 3.0. Hemolysis means the cell walls will rupture. Volunteering in a lab, Liam was asked to dissolve the cell walls of some red blood cells and isolate the contents. This is a pretty practical thing to need to do. If you do cell biology, you want to get the stuff out of the cell so you can study it. So Liam wants to add acetic acid to 100 ml of a suspension of red blood cells to gently rupture the cell walls. What is the mass of acetic acid that Liam should weigh out? Okay. So, I'm going to need a piece of paper. Alright, so what do we know? So there's a lot of going on here. Let's think grapes. So grapes, what are we given? Question 5. So in terms of what we're given, we're told we want a 100 ml solution, which is 0.100 liters. We're told the pH equal to 3.00, which means we can make a conclusion about the concentration of hydronium. Is 10 to the power of negative 3, which is 0.00100. Or rather, the concentration of hydronium is equal to 1.00 times 10 to the negative 3 molar. And we know we have acetic acid. And what do we know about that? We know the molar mass of acetic acid is, well, maybe we don't know, but we could probably find it. We can also figure out what the heck acetic acid is. It's on this sheet. Acetic acid. It's right here. So CH3COOH. It's vinegar. So I can just look through here and count the carbons. 12 and 12 makes 24 for the molar mass. Oxygens weigh 16 and 16, so that's 32. Plus 24 is 60. Plus 1, 2, 3, 4 hydrogens, which each weigh 1, so it's 64.0 grams per mole. You can slow that down if you like, but we've done enough molar mass questions where, especially even in this exact note package, that I think you can probably get the gist. What are we required? We want to know what weight of acetic acid should Liam measure to make this. Okay. So to do this, we are going to compare and to answer this, we need to know the concentration of acetic acid. If we know the concentration and we know the molar mass and volume, we can find the mass. That's not so bad. But in order to know how to do that, we need to take this information about how many hydroniums this stuff created, and that will tell us something about how much stuff we had in the first place. Okay, so we're going to use a rice box for that. So I just kind of zoned out. I was listening to Chance the Rapper and just enjoying the music for a while. I listen to music in the background while I make these videos. Alright, so what do we got here? We know the concentration of hydronium is 1.00 times 10 to the negative 3, which we know is the same as the concentration of acetate. And we know they start with 0. These guys get pretty consistent after a while. So we don't know the concentration of acetic acid. That's what we're looking for. So we're going to subtract here 1.00 times 10 to the negative 3. It's going to give us x minus 1.00 times 10 to the negative 3. Now, a lot of 1.00 times 10 to the negative 3. I'm going to let 1.00 times 10 to the negative 3 equal 10 to the negative 3, which it is, for my calculations. Because I'm not going to lose any rounding here. I'm just going to remember I have 3 sig figs, and that's going to let my calculation become a little simpler there. So my acetic acid, my Ka is 1.8, and that's equal to 10 to the negative 3 squared over x minus 10 to the negative 3. All right. I'm going to do this little switcheroo here that we've been doing in the last few questions just to save a bit of time in these questions. I'm also going to say that's going to be equal to 10 to the negative 6 over 1.8 times 10 to the negative 5. I'm also going to divide these guys. So 10 to the negative 6 divided by 1.8 times 10 to the negative 5. We get 0.555. Okay, negative 10 to the negative 3 is equal to 0.0556. I'll just round it there. And I'll add 10 negative 3 to both sides. So that's 0.001, of course. So when I add that, you can see it doesn't really change the value much. This is what 10 to the negative 3 is. Oh, so 566 instead of 556. Okay, that's fine. And that's our concentration of, that's our X, our concentration of acetic acid. So we just found the concentration of acetic acid is 0.0566 moles for every liter. All right. And that's not what we were asked. We were asked what's the weight of acetic acid that Liam should measure. However, we know the volume, we know the molar mass, so at this stage, things get pretty straightforward. So we know 1.00 liters times 0.0566 moles for every 1 liter. And we'll multiply that by the molar mass, which is 64.0 grams for every 1 liter, 1 mole. And moles cancel, and liters cancel. And we get 0.1 times 0.0566 times 64. 0.362 grams, which you can imagine weighing out. And there we go. That's it. Okay, let me know if you have any questions with any of those guys.